At the start of the 1980s, a new kind of business aircraft appeared. It was called the Learfan 2100, and it promised to make the King Air obsolete. It was sleek, fast, futuristic, and built around the idea of giving owners the speed and status of a small jet, but with the fuel burn of a turboprop. And for a moment, people believed it, because nearly 280 buyers put money down before the airplane was certified, and the British government backed it with millions. And Bill Lear, the man who had already changed business aviation with the Learjet, looked like he was about to do it again. But then, he didn't, because the Learfan collapsed under the weight of its own ambitions. And to better understand why the Learfan failed, you have to know what Lear was actually trying to build. Bill Lear had been carrying the Learfan idea in his flight bag for decades. As far back as 1954, he argued in Skyways magazine that a twin-engine aircraft driving one pusher propeller could outperform a conventional twin by cutting the drag, weight, and complexity that came with hanging two engines out on the wings. But what really troubled Lear was what a conventional twin does when one engine quits. Lose one engine and the other is still pulling hard from one side of the aircraft, so the airplane yaws and rolls toward the dead engine. At low speed, the rudder may not have enough authority to stop it, which is exactly the danger zone during takeoff. So while a single-engine airplane that loses power simply becomes a glider, a twin with one engine out can become a fight for control at the worst possible moment. And that was the problem Lear wanted to design out. But seeing the problem and solving it were two different things, and the idea had to wait, because Lear had other fires burning first. He built aircraft radios and navigation systems, helped make autopilots practical for business aircraft, and then created the Learjet, the airplane that showed corporate aviation it did not have to plod around at piston twin speeds anymore. Each of those fires built the reputation that the pusher would later trade on, so that by the time he came back to the idea, he was Bill Lear, the man who had already bent business aviation once, and the industry listened on that reputation alone. What he came back with was not nostalgia, because in the mid-1970s, Lear designed a long-range business jet called the Lear Star 600 and sold the production rights to Canadair. But as Canadair developed it, the airplane drifted further and further from what he had imagined. The fuselage grew wider, and by the time it emerged as the Challenger 600, it was no longer the lean, fast aircraft Lear had drawn. He reportedly mocked it as Fat Albert. Having watched someone else fatten his design, he wanted one more aircraft that was unmistakably his. So Lear went back to the pusher, and this time the market conditions were right. The 1973 oil crisis had changed the whole fuel conversation. Corporate jets were still fast, but they were thirsty, and every hour in cruise came with a fuel bill that made accountants lean over the pilot's shoulder. Turboprops answered that bill, but raised another problem of their own. Despite being cheaper to run, they were slower, noisier, less glamorous, and in the executive world, they looked like the sensible choice rather than the exciting one. Each side of the market, in other words, forced a compromise the other side refused to make. That gap between them was exactly where Lear aimed. What if you could build an airplane that cruised like a small jet, climbed into the flight levels like a serious business machine, crossed real distance, and still burned fuel like a turboprop? What if you could give an owner the speed, altitude, and ramp presence of a jet without the fuel flow that made the jet painful to operate? That was the mission profile, and it aimed well past the King Air, the Cheyenne, and the Conquest. But a mission profile is only a wish until the airframe earns it, so Lear went after the two things that punish every airplane: drag and weight. And drag was the first enemy, because every conventional twin had two engines and two propellers hanging out in the airflow, right where Lear wanted clean air. Despite that this layout is proven, maintainable, and structurally straightforward, it pays for all of that in drag. And paying in drag was the one bill Lear had decided he would not settle. Lear buried both engines in the rear fuselage, put one propeller at the back, and left the wing clean. From the outside, the aircraft looked almost like a small business jet that happened to push itself with a propeller. And the bill for that clean wing came due inside the fuselage. Inside the rear fuselage, Two Pratt & Whitney Canada PT6 turboshaft engines each spun their own driveshaft into a single combining housing, where the power merged and came out through one output shaft to the propeller. Clutches sat in the system to disconnect whichever engine failed, so a dead turbine would not drag the live one down. That much was clever, but it carried a hidden cost. Where a conventional twin keeps its two propeller systems completely separate, the Learfan funneled both engines through one final drive path, and that made the gearbox the single point of failure for the entire propulsion system. The trade ran in both directions at once. If the gearbox behaved, losing an engine became a non-event, a smooth slide to half power through the same propeller, but if it failed, both perfectly healthy engines could sit there making power with no reliable way to turn it into thrust. In effect, Lear had taken the conventional twin's worst habit, the urge to yaw and roll toward a dead engine, and locked it inside that gearbox, which meant the FAA was always going to hold it to an extraordinary standard. The frustrating part was that he did not have to make that bargain at all. There was already a proven way to keep centerline thrust and true engine independence at the same time. The push-pull layout, the arrangement Cessna had put into production with the 337 Skymaster. Put one engine at the nose and one at the tail, each driving its own propeller on its own shaft, and lose an engine. The surviving half carries on alone, with nothing the dead engine was doing having any hold over it. But a push-pull pays for that independence with two propeller installations and all the drag they carry, and drag was the very thing Lear had set out to design away. So that solution was closed to him before he started. So Lear reached the same calm handling from the other direction, buying the clean airframe, but surrendering the separation that makes redundancy real. Where the push-pull designers had beaten the conventional twin's danger outright, Lear had concentrated it into a single box and bet the whole airplane that the box would hold. He would not live to see whether it did. That is because Bill Lear died of leukemia in May 1978, before the aircraft flew. His last words to his wife Moya were, "Finish it, Mommy." From that moment on, every decision that followed was made under the weight of that promise. On paper, the aircraft gave Moya every reason to keep going. It was barely half the weight of the turboprops it was chasing, yet it promised small jet speed, a 41,000-foot ceiling, and a single-engine climb rate that sounded unreal for a business turboprop. 1,900 feet per minute to 33,000 feet. That meant the Learfan could lose half its power and still outclimb most conventional twins running on both. So the trap Lear had spent decades trying to escape was, on paper, gone, and paper was enough to sell it. By 1982, the order book had reached 263 aircraft, peaking at roughly 280, and at $1.6 million each, the nominal backlog was pushing toward $450 million. That backlog pulled in a partner no startup could expect. The British government, who climbed aboard, committing $25 million for development and another $25 million for production at a factory in Newtown Abbey near Belfast, with the promise of 1,200 jobs in a region that needed them badly. But state money never arrives without strings, and the funding came with a condition that the prototype had to fly before the end of 1980. It didn't. Technical problems pushed the first flight past December 31st. And when the Learfan finally left the ground on January 1st, 1981, both sides quietly treated it as December 32nd, so the money was released and the program continued, but only on paper, and paper was about to meet the airframe. Everything sold so far, the speed, the single-engine climb, the weight that made all of it possible, depended on two bets almost no one had certified before. An airframe built almost entirely from composite, and a twin that ran both engines through a single gearbox. A program can carry that much novelty in one system and survive it. The Learfan was carrying it in two, and worse, it was running out of money to pay for either. Take the composite first. The Learfan was built around weight because the carbon airframe was meant to come in at half the weight of an aluminium one, and every figure in the brochure flowed from that. As first advertised, it would weigh 3,650 pounds empty, climb 1,900 feet a minute on one engine, and take off and go around on that one engine alone. Those numbers sold the order book, and all of them depended on the airframe staying as light as Lear had drawn it. It did not. The Composite was one of the first ever trusted with a pressurized cabin, so it had almost no certification history, and when the structure failed under test, the only fix was to add material. The wing cracked during static testing and had to be reinforced. The pressure vessel failed more than once, including an explosive decompression of the first flying prototype at 25,000 feet. The crew recovered the aircraft, but the cause never fully pinned down, so again the answer was more structure. The empty weight climbed from 3,650 to 4,100 pounds, and the single engine climb fell from 1,900 feet a minute to 1,300. The aircraft was getting heavy in the one place it had promised to stay light, and the money was running out alongside it. The initial funding gone by late 1982, and a rescue under the name Fan Holdings, keeping the doors open with nothing to spare. The second bet sat in the gearbox. Everything hung on two engines feeding one propeller through one combining gearbox built by Western Gear, so that losing an engine became a smooth slide to half power rather than the violent yaw of a conventional twin. The engineers knew that running both engines through one box concentrated all the risk in a single place, so they tried to make that box as failure-proof as possible. If one engine died, sprag clutches automatically disconnected it so it would not drag the live engine down. If gear teeth were damaged, the design kept more than two teeth in mesh so the load would not fall on one weak point. And if the oil system failed completely, wax built into the gears would melt and keep them lubricated for up to 5 hours at reduced power. So the gearbox was not just a gearbox, it was the entire safety argument of the airplane. It was still a single point of failure, and the FAA treated it as one. The agency held the Learfan to a standard some put at 2 to 3 times stricter than a comparable aluminum aircraft, and after 200 hours of inspection it found the gearbox wearing too fast and refused the certificate of airworthiness. A heavier wing had only made the aircraft slower, and a reworked bulkhead had only made it later. But a gearbox the regulator would not trust made it pointless, because the entire reason the Learfan existed was that 2 engines made it safe, and 2 engines were worth nothing if both turned one shaft the FAA could not certify. In February 1985, the British government confirmed there would be nothing beyond what it had already committed, and the program needed more time, more testing, and more cash, with none of the 3 in sight. In May, Moya Lear stopped it. The teams in Reno and at the Belfast factory were let go, the doors closed, and the 3 prototypes became museum pieces. 2 months later, Learfan Limited filed for liquidation. $7 million in assets against $475 million in liabilities, more than $250 million spent, and the certified aircraft it was all meant to produce had never existed. So, that's it for today's video. Don't forget to like, subscribe, and ring that notification bell. It goes a long way for us.